Okay, so today we're going to now redo all the operations that we learned last unit, dot product, cross product, except we're going to do it with algebraic vectors. And we're going to see this is one of the benefits of doing it with algebraic vectors because we don't require a picture anymore. And we sort of discovered that yesterday. So if you look at today's stuff, we're going to actually do the dot product of u and v. First off, can someone tell me whether we are talking in this particular example if we're in 2 dimensions or 3 dimensions? Rebecca? That's correct. I hope that you got that right, by the way. We can tell that this is in 3 dimensions because the components of u are u1, u2, and u3. If it was 2 dimensions, of course, we just have u1, u2. And v, of course, is v1, v2, v3. So now when we take the dot product, remember dot product is multiplication. It's actually quite simple. The dot product is simply taking your x components and multiplying them together, your y components, multiplying them together, and your z components and multiplying them together. And so the dot product then is u1 times v1, u2 and v2, and u3 and v3, and then you add them up. Remember, the dot product produces a scalar. It's a single number. And so it's just found by taking the product of the x's, the y's, and the z's, and then add them up. So let's look at an example. So in example 1, we have u is 3, 1, 2, and v is 4, negative 2, 2. And so if we're going to find u dot v, we're just going to multiply the x's. So it's 3 times 4, which is 12, plus 1 times negative 2, so plus negative 2, and 2 times 2 is 4. And then we'll just add these up. 2 plus negative 2 is 10, plus 4 is 14. And so then u dot v is 14. Now, that's as simple as dot product is. Just a matter of multiplying the x's, the y's, the z's, add them up, boom, you get an answer. One of the things we can do, though, is use the formula for dot product from last unit to answer this question. So because we don't have a picture, we can't easily see an angle. So one of the advantages of the geometric vectors is that you can see the angle between them. You physically see it. When you do the dot product without drawing this picture, which is in 3 dimensions, it's difficult to find the angle. So we're going to use the formula from last unit. So if you notice, if I do u dot v equals the magnitude of u times the magnitude of v cos theta. Right? That's still true even though we're in algebraic vectors here. But if I wanted to solve for theta or cos theta, I can leave this here and have u dot v being divided by the magnitude of u times the magnitude of v. So we're going to use that concept to answer this question. So we're going to take this and apply it over here. So cos theta is u dot v. So on the top, it is, since they're algebraic components, we're going to do 3, 1, 2, dot 4, negative 2, 2, over the magnitude of u and times the magnitude of v. So remember from yesterday, to find the magnitude is you take the sum of the squares, square root of the squares. So for u, it is the square root of 3 squared plus 1 squared plus 2 squared. That's the magnitude of u. And the magnitude of v, square root of the squares, 4 squared plus negative 2 squared plus 2 squared. Now, I don't expect us to write that down every time, but it will be helpful here. So on the top, it's dot product. Well, we just figured out the dot product is 3 times 4 is 12, plus -2, plus 4. I mean, that's the same as what we did in part A. The bottom, square root of 9 plus 1 plus 4. That's probably what I'd expect you to do in one step there. 16 plus 4 plus 4. And so on the top, we get the 14. And on the bottom, we get the square root of 14 times the square root of 24. Remember that this is going to get us an answer for cos theta. You'll get some big long decimal or whatever. I don't expect you to write that down, but do remember that we're going to have to push inverse cos. And I think if you check your answer, you get 40.2 degrees. So we'll get you to just double check that on your calculator. Pause if you want. But this is the end of first example.